I wanted to give you guys a live demo of how this whole thing works. Like I described, we'll have a setup here of an online e-tailer with a auctioning system doing the front end, which is taking the load, and the back end, we will have a back office integration scenario. So let me bring up to the stage Perry Krug, who will show us the demo of this live system. Welcome, Perry.
Hey, Ravi. Hello, everybody. Welcome. Thank you all for joining us. Do that, do this. Okay. See? Good. So, as Ravi said, we wanted to give you a demo of what's capable with Couchbase Server end to end. And we thought with the recent success of the Alibaba IPO, we would show you all how easy and simple it is to create an auction website of your own. So here we have an application running that was built with our latest Node.js 2.0 SDK. It's completely redesigned, and I hear from our developers that it's fantastic. It's got a reactive design using an Ottoman ODM, and it's available for you to use today. Here's a very short sample of the code that's running this. Our engineer, Todd Greenstein, and some of others built this in really just a couple days. So we have here a site running in the US in our Salt Lake City data center, and we have a site running in London in our data center over there. And just by adding a few bids here, we can increase that on the Salt Lake City side, see that it's propagated over to London. At this point, I want to open this up to all of you as well to bid on a brand new 2014 Maserati in beautiful, beautiful condition. You should have the link in your Twitter stream, or you can go to this up here, minus the URL if you can see that.
Fantastic. Yes, please, we encourage you. There'll actually be a winner that we'll announce at some point if we get this all right. But sorry, it won't be the Maserati.
We will have a $100 Amazon gift card for the winner of this at the end of the session. So please feel free to participate. But now we're going to go from the application down into the clusters that are running.
Sure.
So over here on our Salt Lake City side, I have a brand new 3.0 cluster running. If we dive into the data, we see that it's doing about 150,000 operations per second.
Is that like the regular load that you will on a sort of Monday afternoon kind of?
This is pretty much the baseline load that we expect from the application, handling the daily or hourly reads and writes. You can see we're doing about 100,000 reads per second and about 8,000 or 9,000 writes per second.
Fantastic. And how does it look on the other side of the pond?
Sure. So if we switch over to London, we see that we have a similar setup here. Same data set, running a much lower load, and all we're doing is replicating the writes from our Salt Lake City cluster over to London.
Beautiful. Now, the application characteristics on both these sides are very different, right? So on the e-commerce side, this is how it looks on a sort of a daily basis. But let's say you hit the Black Friday, the proverbial day when actually you get all business done. People are shopping like crazy. Is this system provisioned to take on that sort of a load?
It absolutely is. And let me show you what we think these are capable of. I'm going to start up a little more load here and here. We should see a little bit of spike in the traffic. The first one is done now. The second one should come up in just a second. We're topping out just around 1.2 million operations per second.
Did you say 1.2 million operations a second?
1.2 million operations per second.
And you're running all this load, standing here, running some scripts in the background, and that 1.5 million load that you're seeing there is running on those 5 nodes that you earlier showed us.
Yeah, so we have 5 nodes set up in the data center. They're pretty standard commodity servers. I think we have 9 or 10 cores of CPU and about 13, 15 gigabytes of RAM. So nothing too special.
Amazing. 1.5 million operations per second. A bulk of them reads, but nonetheless, that's what typical systems will take. And we are running this on 5 commodity hardware.
Yeah, and this is live running now.
Fantastic. We are not fooling you. This is all running live someplace. Yes, it's running in some data centers, and yes, we have some of our IT folks monitoring the system closely and stuff like that. So this is all running on bare metal. Now, on the other side, for the London, the application that we're going to be running here is very different. This is where the back office business analysts will be actually looking at the patterns and looking at their business analytics sort of function. And you mentioned it's running on 3-node systems, so I'm assuming it's provisioned for far less than the e-commerce side.
Yeah, we decided we didn't have to handle quite as much load from it. Wanted to focus more, as you said, on the analytics. So we used the same hardware, but we only have 3 nodes provisioned. And using the new tunable memory capability of 3.0, we're able to store the exact same data set in a much, much smaller RAM footprint. So whereas Salt Lake City is using about 45, 46 gigabytes of RAM. London, storing the same data set, is only using about 6.5 gigabytes of RAM.
Wow. So the memory footprint here is far less.
Yeah.
But still, when I see that graph, looks like there is a scope for further reducing the memory requirement on the system. Would you agree?
I think we could probably take it down a little bit. So right here from the admin screen, I'm going to go in and edit this bucket here on London. You see right now we're using about 3 gigabytes per node. I'm just going to shrink that down to 2 gigabytes or 2 gigabytes, maybe 2,500 gigabytes, so that we can reduce the RAM further, make more space. By saving that and then clicking back in here, we can see that the memory is dropping down, or the watermarks are dropping down, and the memory used is going to come right down with it.
Fantastic. So that's how you sort of tune the memory in the system, based on your business requirement or based on the scenario that you're actually running into. You can provision the systems differently. That helps with the ability for the businesses to sort of, in an agile way, react to their market demands or react to the nature of business on a given day. We made it so simple. All Perry did here was to sort of switch on, switch off a few things, and now the application characteristics are very different. And the system characteristics that we have provisioned for that is also very different. Now, could we look at the actual the application and start bidding and show so the whole idea was that the bidding is happening, the e-commerce side is running, and on the back end, somebody wants to spend $38,000.
Doug, did you spend this much on the car to begin with?
Oh.
Good Lord.
Well, maybe this car is worth spending that money on because it's driven by an elderly gentleman for commuting purpose only. Maybe it's as good as new. So maybe it's worth it. So what we are seeing here is that the bid is getting placed on the Salt Lake City side, and Perry will go do that. And instantaneously, you see that bid on the London side. I mean, it's near real time.
Yeah, sure. My bid is having a hard time getting through. There's so much load on the system running at 1 million operations per second.
People are going crazy. This is what happens if you're Alibaba or one of the 40 thieves.
Just like that. So what we can see here is most of the traffic, or all the traffic, is going out of Salt Lake City now. It's being replicated over to London and showing up there. From an analytics perspective, we can just click on this link, this button here, and get a bid history pop up of all of the bids that have happened here.
Wow.
And this is actually running off of a Couchbase view off of the London system. And because we have the RAM to RAM cross data center replication, and because the DCP is feeding those views as well, we have pretty much real-time consistency across these 2 data centers.
Fantastic. So what you actually are seeing is in real time, bids are getting placed in one data center, which are getting replicated across to the other data center, where you have provisioned the system entirely differently. And yet, within milliseconds, you're actually seeing these bids in that query that we do. So this is because the indexes are getting updated in near real time, where we have seen considerable speed up because of the database change protocol. And Now, Perry, I remember you earlier mentioning to me that you had set this up as a bidirectional XDCR. So, sometimes can people from London bid on this as well?
Yeah, absolutely. So we've set this up, as I said, bidirectionally. Both clusters are active-active. And so we have the same application running not only for analytics purposes, but really to give our UK brethren a much better browsing experience so they don't have to come all the way over. So in the same respect, I can enter a bid if someone will let me get a bid in here. Mother piece. Good. And then you see it was replicated over here, and I can look at the view when that comes up here. My bid did make it in. Someone is on top of us there, but this whole system is working bidirectionally.
That's fantastic. So you can actually set up the system to do bidirectional XDCR, which gives you the ability to move data closer to your users, and thereby they get better latencies because this data is hosted closer to them geographically. Perry, I'm getting greedier because all these things are working like a charm.
Always pushing.
I just saw 1.2 million out there. I'm just getting greedy. Is there any way? And also, I do see that this is backed by our IT guys doing diligently opening ports and keeping things, in a very sanitized way for us to get the best performance results. But more and more businesses are sort of cloud friendly these days. They want to deploy such systems in the cloud. Do you think we can set up at least a similar capacity system in the cloud, spin it up, and see this kind of performance out there?
Ravi, I thought you might come up with some silly requirement like that. So yesterday or the day before, I went ahead and did just that. I took a couple instances out of Amazon, C3 4 extra larges. If anybody knows what that means, it's about 16 cores worth of CPU and 30 gigabytes of RAM. A little bit higher than what we had in our data center.
Amazing. And is there any performance you can actually show
I think
me?
I might be able to show you something here. So I took the same data set, I copied it up there, I took the same workload, the same application, and we're running it up there. Let me see what she's talking to me now.
I'm putting Perry on a spot here because I know he was playing with this. So let's see what
I was hoping it would be a little bit higher, but it looks like we're topping out around 3 million operations per second.
Just 3 million operations per second, and Perry is unhappy. This is less than 24 hours old in the sense that he was trying to have a backup system set up just in case something were to go. I was asking him for a plan B. My plan C was just to talk to the slideware here, but plan B was to have something somewhere else outside of our data center. So earlier in the day today, when he mentioned that something like this could be doable, I just definitely wanted for him to share that with all of you. 3 million operations per second, sustained load, it's been running there forever. I think that ought to keep any of the e-commerce sites happy for a while. So fantastic, Perry. Is there any result to all this bidding war that has been happening there?
Yeah, so I think in 10 seconds or so, we're going to close the bidding. We're going to see whoever gets their last bid in. We're at quite a high amount here. Hope the car is worth it. Todd, you wanna close that on us? Is it closed? It's closed. So whoever is going by the handle KK, you are now the proud owner of our CMO's Maserati for the very bare minimum price of only $71,000.
Fantastic. Lovely. The winner, sorry, it won't be the Maserati, but there will be an Amazon gift card. Appropriately.
We're almost the same. So come find us later on up here, and we'll pass that off to you.
Fantastic. Thank you,
That's all I
Perry.
got.
Appreciate it.
Yep. Thank you, Ravi.
Phenomenal.